Okay, Assalamualaikum warahmatullahi wabarakatuh and good day for all. Okay, for this video session, I will teach you on how to use the Motionview software from Altair for suspension analysis and also full vehicle analysis. Okay, if you already download the student version for Altair HyperWorks 2020, you can search for your software is HyperWorks Desktop. Okay, HyperWorks Desktop 2020. Okay, for those who are using the HyperWorks 2017, you can directly search for the Motionview 2017. Okay, right. So you click on the HyperWorks Desktop 2020. It will appear like this. Okay, it will appear the HyperWorks, which is actually is a HyperMesh software. Okay, so you just click OK, and then you change it at the bottom left icon here. You can change to the Motionview. Okay, you can change to the Motionview. So you just click yes, and then it will go to the Motionview software. Okay, you could go to the Motionview software. Okay, so this is a interface of the Motionview here. Okay, at the left side you have a project, you have a session. Okay, in the project object we have a bodies, dataset, markers, point, vectors, and miscellaneous. And then you can seems like a hypermesh actually. Okay, but different function. Okay, okay, how we want to start for the vehicle dynamics or suspension analysis. First of all, you go to this icon, which is the file and the gear icon, which is a load preference file. You click on that. Okay, you choose the MBD vehicle dynamics tool. Okay, MBD vehicle dynamics tool, and then you can load it. Okay, if you not load the MBD vehicle dynamics tool, it will not appear the vehicle dynamics punya analysis. Okay, so you need to load it. Okay, after you load, okay, and then first we want to set the suspension assembly first. Okay, and then you go to the model. Okay, you go to the model here. Okay, so in the model you have an assembly wizard, attachment wizard, set wizard path, material, implicit graphics, data summary, and topology summary. Okay, if you want to set the model, you go to the assembly wizard, and then it will appear in the browser here. Okay, so you can choose either you want to set up the front suspension assembly for front end vehicle, or rear suspension assembly, or full vehicle assembly. And we have a function for 2020, we have a test rig and also the powertrain model. For 2017, you don't have this. Okay, the test rig and powertrain model, you only have a three of this: front end, rear end, and so full vehicle. So for example here I choose the front suspension assembly. So you click to the next. Okay, you click to the next. Okay, and then you can set if you want to put the drive line or not. Okay, if you don't want to put the drive line, you just choose the no drive line. If you want to choose the front wheel drive, you can choose front wheel drive or rear wheel drive or four wheel drive. Okay, for example I choose the front wheel drive here. Okay, so you click on the next, and then you can set the parameter for your system. Okay, so the vehicle body is body fixed to the ground. You don't have any choice. Okay, and then you can choose if you want to put the subframe model or not. Okay, if you want to put the subframe, you can put. Okay, for example I put the front subframe. Okay, and then this is a type of the suspension you need to choose. Either you want to put as a McPherson suspension, one piece lower control arm. The second one is the front suspension, two piece of the lower control arm. And then you have a front SLA. Okay, one piece, front SLA, two piece, and also multi-link suspension. Okay, so it's depend on your what you need to do. Okay, what type of suspension do you need to analyze. Okay, you can choose it. Okay, I choose the front McPherson one piece lower control arm, and then steering linkage. In the steering linkage, you have a rack pinion steering, parallel steering, and double ideal steering. Okay, it's depend. Okay, and you have, if you want to put the powertrain, You can put it either transverse or variable mount transverse. Okay, if you don't want, you just put none and then go to the next. Okay, so this is a subsystem of the steering. Okay, you have a steering column, okay, or none if you don't want to put the steering column or steering boost. Okay, okay, if you just put like this as a default, you go to the next. So this is a spring dampers and stabilizer bar, okay, for the front strut. If you want to put it as a inline joints or cylindrical joints or deformable, okay, I put as a inline joints. And if you want to put the front stabilizer bar, you can choose either step bar with the link or two-piece step bar, okay, either one. Okay, if I don't want to put any stabilizer bar, you just put none. Okay, so next is a jounce and rebound bumper. So jounce and rebound bumper is at the strut. Okay, bumper at the strut. If you want to put the jounce bumper, you can put front external jounce bumper, external bumper property space. So it depends. Seems like a rebound. If you don't want to put it, you just put none. Okay, so this is the draft line. Okay, since you put you set as a draft line, so it will have an independent forward. Okay, and then you click on the finish. After you set all the subsystem, you click on the finish here. Okay, and it will loaded the front suspension assembly for the McPherson suspension. Okay, so okay, so for the motion view, it seems like the hypermesh for the mouse controller. Okay, you need to click on the control and left click mouse for rotation. Okay, the middle scroll for zoom in, zoom out, and also the left click mouse for the pan or translate. Okay, so this is a suspension assembly here. Okay, okay, what you see in the motion view model, you have since you choose the McPherson strut, you have one piece of the lower control arm here. Okay, you have a drive line here. Okay, this is the drive line. You have a steering system here, rack and pinion. We have a strut, consists of the spring and dampers. Okay, we have a subframe here. Okay, this is a subframe mount. Okay, this is a wheel. Okay, and you see on the left side for project here, the model browser here. Okay, in the model you have the bodies, data sets, markers, point, vectors. Okay, here. Okay, in the bodies you have a ground body here. Okay, dataset solver units. Okay, in the motion view, the default unit is a Newton, millimeter, kilogram, second. So you can change it in the dataset. Same as a gravity. Okay, gravity unit, if you want to off or on, you can off or on here. Okay, global marker you don't need to change. And then you go to the body. Okay, this is a body fixed. Okay, we have several part here. The first one is a body fixed to the ground. Okay, here, so vehicle body. This is the properties of your body. Okay, bodies. Okay, if you want to change the mass or initial properties, you can change it. Okay, if you have the actual mass of your suspension body, okay, it's not suspension body, it's a vehicle body, you can change it for the mass. Okay, and also the initial properties. Okay, and you have a joint here. Okay, joint here, this is a represent the body vehicle. Okay, and then we have a front subframe here. Okay, we have a body, subframe body. You can change the mass, you can change the initial properties here. Okay, and we have a bushing for the front subframe here. Okay, this is a front bushing, front subframe mount, and also rear subframe mount. Okay, okay, if you have your own properties of bushing stiffness, okay, you can change the translational stiffness here and also rotational stiffness here. Okay, you can change it if you want to change. Okay, if you want to change, if you have your own data, your actual data, you can change the value of the stiffness for translational and also rotational. Okay, and then next we go to the front McPherson suspension. Okay, in the front McPherson suspension, we have several part, which is the first one is a knuckle here. If you click, it will highlight. Okay, it will highlight. Good. So this is a knuckle. So in the knuckle, we have a mass, we have a initial, okay, and also we have a lower control arm here. Okay, we have a lower control arm. So this is a lower control arm. Okay, in the lower control arm, it consists of the bushing, two bush here, and we have a wheel. Okay, we have a wheel properties here, and also we have a wheel hub. Okay, wheel hub in the center of the wheel. Okay, wheel center. Okay, and then we have a bushing for the lower control arm front bush here, and also lower control arm rear bush. Okay, and also we have a joints here. It's a lower ball joint here, wheel spindle, and also wheel hub. Okay, so next is a front strut. Okay, in the front strut, if you click front strut, okay, it will highlight the front strut here. In the front strut, we have a two part, which is a strut rod. Okay, strut rod, upper strut, and also the lower strut. Okay, in the upper strut and the lower strut. Okay, in the joints, you have a few of joints. Okay, strut tube, lower strut, upper strut, and strut upper bush. Okay, right. So next is a rack pinion steering. For the rack pinion steering, so this is a left hand drive. Okay, so you have a consist of a tie rod here. Okay, this is a tie rod. We have a rack system, rack housing, and also the pinion here. Okay, the pinion system. Okay, and then we have a joints. We have a joints, rack translational joint, pinion joint, tie rod, outer tie rod. Okay, and then we have independent forward. Okay, this is a drive line. Okay, independent forward. This is a drive line. We have a body of half shaft plunge body here, half shaft, carrier, output shaft, and pinion. Okay, so at the border browser of your left side, this is all the parts that include in the suspension assembly. Okay, okay, this is all part. If you want to change the parameters, for example, the bushings, the joints, the mass, you can change here. Okay, but if you want to change the hard point, okay, hard point of the suspension, you can change. You can go to the model. Okay, this is, we have a data summary here. Okay, model data summary here, so it will appear the hard point of your system, suspension system. Okay, for all parts. Okay, what's mean the hard points? The hard points means the coordinate for each point of your suspension assembly. Okay, so for example, we have a vehicle body here, center of gravity. So 2150 mm for the X location, Y location is a 0, and Z location is a 1250. Okay, so for the subframe, we have a several point of the subframe, and also for front MacPherson suspension, strut, and also steering, and have a driveline. Okay, so all this we have set as a symmetry. If you change the left, it will automatically change the right. If basically, if you want to model in the suspension assembly, okay, we set as a symmetry, just a simple one. Because if you set not symmetry, you need to change for the left, you need to change for the right. Okay, for example, I want to change the uh, I want to change the lower control arm. Okay, lower control arm, front bush. Okay, here I close blue. I need to close up first. Okay, so this is a parameter of the front bush. Okay, front bush here. If I want to change the coordinate or the hard point of the LCA front bush, let's say in the X direction, I want to change to the 900. So it will move. It will move the hard point here. Okay, for example, 600. It will change the hard point. Okay, so it will change the hard point for the left and also for the right. Okay, okay, so this is how you want to change the hard point. Okay, you go to the model, you go to the data summary. Right, so So for the next lat 4, you have to do the hardpoint changes to see the uh, condition of the suspension if you change the hardpoint. Okay, so this is a front suspension assembly. Okay, if you already set up this, okay, you want to run the analysis. Okay, the suspension analysis. So how you want to run the suspension analysis? You go to the analysis here. Okay, and then you choose the task wizard. You choose the task wizard. It will appear like this. Okay, in the task wizard, it have several suspension analysis. For example, here we have a kinematics and compliance analysis. We have a static ride. We have a static roll. We have a single wheel analysis, steering analysis, static load, trim height, tire envelope analysis at the wheel center and also at the ball joint. Okay, for example, I want to choose the kinematic and compliance analysis. Okay, so you go to the next, finish. Okay, finish. So you need to set up the vehicle parameter first. Okay, if you have your vehicle and front, okay, independent suspension, tire static load. If you have your own data or for the tire static load radius, you can put it. If you want to put a default, you can put as a default. Okay, you have a tire vertical spring rate, vehicle CG height. Okay, if you want to change the vehicle CG height, you can change wheelbase. Okay, based on your vehicle, what is your wheelbase parameters? Okay, front braking ratio and front drive ratio, exhaust ratio and vehicle, the total vehicle weight. Okay, okay, you need to put the parameter as actual vehicle. Okay, next, this is a kinematics and compliance parameters. You need to put the jounce travel in right. Okay, jounce travel means the test rig movement. Okay, test rig movement up 100, rebound downward 100 mm, wheel travel in roll, okay, 100 mm, maximum lateral force 4000, longitudinal 4000. This is a default value. If you have your own value, you can change it. Okay, and then you click on the finish. Click finish, so it will appear the test rig here. Okay, so this is a test rig for the kinematic and compliance or KNC analysis. Okay, this is a test rig. Okay, right. So if you already set up the analysis for the suspension, you can run it. Okay, how you want to run? You click on the green icon here. Okay, green icon, run solver. Okay, you click on that. You need to first save and run the current model. You put the directory that you need to run. So I'm suggest you put it in the one folder so that you can easily trace the result file. Okay, for example, I put the name is a KNC, and it will save as type for XML. Okay, XML, you cannot change it, you don't need to change, and you save it. Okay, so the simulation type is a quasi-static. Okay, remain by default. Analysis type is a kinematics and compliance. Script is a motion soft, and time is 90. Okay, so it's based on the default. So better you cannot change. Is the end time is state good for this simulation. Okay, the print interval you can change. This is a step size. If you want to put 0.01 step size, it will make it your punya result tu more accurate. It's not more accurate, the data is more, and the runtime is more longer. So you just can run it. Okay, you click on the run, it will appear the message log here. Okay, and it will run it. So you need to wait until it finish run time. Okay, after finish, it will appear like this. Okay, and solver screen of output. motion soft job completed. So you need to make sure it already run 100% completed. Okay, so after that you need to view the result. You just click on the result here. Okay, you click on the result, it will open up the hyperview. Okay, it will open up the hyperview. Okay, you just click close. So it will open up the hyperview in order to see the animation of your analysis. Okay, for the load model and result, okay, you need to find out the H3D file. Okay, let's say you open up, you need to open after this. You open up, if you want to see the animation, you just open up the hyperview software. Okay, and then you can load the model and show the result. You search or you find the H3D file here. Okay, the same result, the same file for both model and also the result. Okay, so how you want to see the animation, you just click on this. Okay, you click the animation play here, it will show the KNC analysis. Okay, KNC analysis here. Okay, so this is how the KNC analysis. So the KNC analysis consists of the steering movement, turn left, turn right, and also bumps and rebound. Okay, bumps and rebounds. Okay. Okay, next, it's not only we want to see the animation, we want to see the plotted graph of the result. Okay, the plotted graph of the result. Okay, how you want to see the plotted graph? Okay, you can change here. Here, the view panel here, the view panel. Okay, you change to the uh, to view here. Okay, side by side. Okay, you click on the second side view. You click on the icon here, you go choose to the hypergraph 2D. Okay, hypergraph 2D. Okay, here this is how we want to plot the graph. Okay, how we want to plot the graph. So the data file here, you need to upload the data file result. Okay, here you just click open. You search for the ABF file. Okay, your name of your analysis and also .abf file. So you click on the ABF file, open. It will uploaded the result for this KNC analysis. Okay, okay, if you want to plot the result graph plotted, you can plot the graph. Okay, for the x-axis here. Okay, for the x-axis here, you need to choose either you want to plot against times or you can plot against any subsystem. Okay, for example, any subsystem here is we have a wheel vertical displacement, toe steer camber, lateral force, longitudinal force, roll steer, right steer. Okay, okay, I just want to plot against time. Okay, against time, and for the y-axis, you can change you can choose the request subsystem here. You can choose against what means by wheel vertical displacement or toe steer camber, caster, and kimping inclination, and you just tick the preview if you want to set as a automatically. If you don't want to tick the preview, you just click on the apply. Okay, so let's say I want to click on the preview, so it will appear the graph like this. Okay, the graph like this. Okay, so what means by this graph? This is a graph of the toe steer. Okay, toe steer camber. So what's mean by result 1, 2, 3, 4 until 8? Okay, so it's not XYZ. So I give you the definition of the result 1 until 8 in the lab sheet. So it's not mean by XYZ. The result 2 means the toe left. The result 3 means it's a toe right. Okay. So okay? You need to find the value. Okay, you need to find the value. What is the maximum value for the toe? For example, toe left, toe angle. Okay, and also the uh, camber angle. Okay, how you want to find it? So you click on this coordinate info. Okay, coordinate info here. Okay, wait, just apply. Okay, go to the coordinate info. You can point to the what is the maximum angle. Okay, what is the maximum toe angle here? You click on this, and then you can find the maximum value here. Okay, the maximum value, for example, this the maximum during rebound. Okay, during rebound, so since this is a negative one, means that is during rebound is a negative 24.95 toe angle. Okay, so the maximum value against during the bounce or bounce travel is a 25.48 degree. Okay, degree. So this is how you want to find what is the maximum, the minimum. Okay, if you want to put during the neutral or 0 0, you can find during this. So is it same like a parameter that you set for toe? Okay, for example, this parameter by default is a 0 degree. So is it you can have the 0 degree here or not? Okay. Alright, so how you want to find the value? You just click on the here coordinate info. Okay, coordinate info. You click, and it will you just put to the highest peak, and then you can find the value here. Okay, and then you want to change back to the plotted graph. You click on this view plot, and then you can change the result. Let's say you want to plot the caster. Okay, for example, caster. So this is a caster angle. Okay, so this is a caster angle. So you have a caster angle here. The value, you can find it. The value one, you click, and this you can find the peak of the. So this is a caster angle. Okay, so this is how you want to evaluate the result. Okay, hopefully you understand how you want to use the Motionview software for the suspension analysis. If you don't, if you have something that you don't know, you can ask me or Mr. Zakaria. Okay, so thank you very much. Assalamualaikum warahmatullahi wabarakatuh.